Few events in the 20th century tested both human endurance and material ingenuity as thoroughly as the Korean War. Beyond the headlines of frozen front lines and shifting battle lines, there is a subtler story, one about timber, structure, and the assumptions modern construction had taken for granted. Engineers discovered that many modern building practices failed under Korea's extreme climate, not due to enemy action, but because of a structural misunderstanding that old carpenters had long known to avoid. Timber beams cracked, joints loosened, and temporary shelters collapsed, not because the material was weak, but because design ignored the dynamic nature of wood. If you value understanding how history intersects with survival and material science, subscribe to Old World Timber. This channel explores the forgotten knowledge of traditional carpentry and the lessons embedded in history that modern builders frequently overlook. The Korean War exposed the hidden weaknesses of industrial construction methods. By 1950, military engineers relied heavily on standardized lumber and prefabricated methods, assuming that uniform dimensions and chemical treatments were sufficient to guarantee durability. So these assumptions, they worked in textbooks and controlled environments, but Korea presented an unforgiving reality. Timber structures built for field hospitals, observation posts, and supply depots often failed, not under bombardment, but under the ordinary stresses of wind, rain, and snow. Reports from American and United Nations units repeatedly cited split beams and warped planks, bridges and elevated walkways sagged prematurely. Officers and engineers were honestly perplexed because, specifications had been followed to the letter. It was not the material itself that failed. It was the way the material was treated as static and unyielding rather than dynamic and responsive. Old World carpenters understood wood differently. They knew it moved, absorbed moisture, and responded to temperature. Their joints were forgiving. Their beams were oriented to flex with load and season. These lessons, accumulated over centuries, were largely absent from modern post-war construction doctrine. The critical mistake was ignoring the natural movement of wood. Wood is anisotropic, meaning it does not behave the same in every direction. Its fibers expand, contract, and twist in response to moisture and temperature. Old carpenters accounted for this in every design decision. Mortise and tenon joints were cut slightly loose, allowing seasonal movement. Beams were quarter-sawn to reduce warping. Roofs incorporated overhangs that allowed timber to breathe rather than trap water against it. Modern construction, in contrast, often assumes wood is static once installed. In Korea, this oversight had immediate consequences. Timber in contact with snowmelt and rain swelled and contracted in cycles the engineers had not accounted for. Joints bound, bolts loosened, and panels cracked. Temporary shelters intended to last months required replacement in just a few weeks. These failures were recorded meticulously in field engineering logs. Observers noted that even when treated lumber was used, structural failure occurred faster than with older, locally sourced timber installed with traditional joinery techniques. The lesson was clear. Design that ignores material behavior is as dangerous as poor materials themselves. Old carpenters built with an understanding of load and stress that modern blueprints often omit. Historic timber construction was not just about stacking beams. Each piece of wood was chosen and oriented according to how it would bear load. Large timbers were positioned so that compression followed the grain, reducing the risk of splitting. Crossbeams were often intentionally smaller to allow main supports to flex. In Korea, engineers initially resisted these methods, favoring rigid joints and uniform cuts. Observers soon realized that traditional carpentry was solving a problem modern engineering had overlooked. Wood is alive, and static designs ignore its natural tendencies. Moisture management was integrated into old designs in ways modern construction often ignores. The war highlighted another overlooked lesson. Timber fails not just because of insects or rot, but because of trapped moisture. Old carpenters prioritized ventilation, drainage, and sacrificial surfaces. Posts were raised on stones, roofs overhung, and joinery was ventilated. Military engineers noted that posts treated with chemicals but set directly into wet ground failed faster than untreated, raised or charred posts. Modern construction tends to prioritize uniformity over responsiveness. After the war, military engineers incorporated lessons from timber failures into manuals and field construction guides. Guidelines emphasized drainage, proper beam orientation, and allowances for expansion and contraction. These lessons, however, rarely made their way into civilian housing or commercial construction, which increasingly relied on chemical treatment and standardized dimensions over responsive design. For survivalists, off-grid builders, and homesteaders, these lessons are invaluable. Timber must be selected, oriented, and joined with movement and moisture in mind. Charred or oil-soaked posts, quarter-sawn beams, and ventilated joints are not decorative, they are functional. Korean War engineers witnessed these truths in an environment where failure had immediate consequences. Respecting material behavior, allowing for flexibility, and integrating passive moisture management are timeless strategies for durability. Remembering these overlooked lessons connects us to centuries of practical knowledge. The Korean War, often remembered for its frozen hills and geopolitical stalemate, also serves as a laboratory for timber resilience and structural awareness. It shows how ignoring centuries of practical carpentry knowledge can lead to unexpected failure, and how integrating material understanding into design protects both life and property. Modern builders often chase speed, uniformity, and chemical assurances, overlooking principles that proved essential under extreme conditions. If you value uncovering these forgotten truths, subscribe to Old World Timber. Share this video with anyone who builds, survives, or studies history with an eye for detail. Some lessons, once forgotten, are costly to relearn.